499 tasks finished in about 2 minutes. One task has been running for an hour. Your cluster is sitting almost completely idle, burning money, waiting for one piece of work to finish. This is Skew, and it is one of the most common ways a well-written Spark job falls apart in production. Start with why it happens, because it is not random and it is not bad luck. It is a direct consequence of how shuffles work. When our fraud job groups swipes by card, Spark hashes each card number to determine which partition it lands in. The goal is even distribution, roughly the same number of rows in each partition, roughly the same amount of work per task, but the hash function distributes based on the key, and the key distribution in your data may not be anything like even. In our fraud pipeline, one national retailer processes a significant fraction of all card transactions in the country, let us say 40%. Every swipe at that retailer carries its merchant ID as a key. Hashing that merchant ID always produces the same partition number because the same key always hashes the same way. So 40% of all the data in the job lands in one partition. One task gets 40% of the work. Every other task finishes quickly. That one task runs until it processes 40% of 2 billion rows, while 499 executors wait. One merchant ID arrow pointing to one overflowing partition, labeled large fraction of all swipes, one partition. There's a second source of skew that is quieter and more insidious. Null values. When your join key contains nulls, where does a null hash to? The same place as every other null, always. If your swipes table has 200 million rows with a null merchant ID, because online transactions sometimes do not carry one, those 200 million rows all hash to the same partition. Null skew is easy to miss because the data looks fine when you inspect it. There are no unusual values. There's just an absence of value, and that absence concentrates in one place. So how do you find it? The Spark UI, specifically the task duration distribution on the Stages tab. Look at the median task duration for a stage. Now look at the maximum. If the median is 2 seconds and the maximum is an hour, one task is holding up the entire stage. That gap is your skew. The bigger the gap, the more concentrated your data is. Once you have found it, you need to know which key is causing it. Add a temporary aggregation. Count rows per key, sort descending. The first few rows will tell you everything. In our case, the top entry is the large retailer's merchant ID. The second is null. Now the fixes. There are 4, and they are not interchangeable. Which one applies depends on what kind of skew you have and what the job is doing. Fix 1. Filter or isolate the hotkey. If the hotkey is something you can identify and handle separately, split the job. Process the large retailer's transactions separately with a different parallelism strategy and union the results at the end. This works when the hotkey has real business meaning and you know which one it is. It does not generalize to unknown future hotkeys. Fix 2. Handle nulls explicitly before the join. If null merchant IDs are genuinely not joinable, filter them out before the join. If they need to be kept, assign them to a synthetic key that distributes them, something like replacing null with a random integer modulo the number of partitions. Null skew is almost always fixable at the point where nulls are produced or ingested. Fix 3. Salting. This is the general fix for skew where you cannot isolate the hotkey. The idea is to artificially break the hotkey into smaller pieces by appending a random suffix. Take merchant ID 12,000, and instead of one key, create 12,000_0, 12,000_1, up to 12,000_9, for example. Each suffix lands in a different partition. The 40% concentration becomes 10 separate partitions, each holding 4%. The catch with salting is that you have to undo it. If you are joining, the other side needs to be exploded to match all the salted variants of each key. A merchant row that used to have one key now needs 10 copies, one for each suffix, so joins still find their matches. That's 10 times the data on the small side. If the merchant cable is 2 gigabytes, it becomes 20. That multiplier is the price of salting, and it has to be weighed against the benefit of distributing the large side. Fix 4. Let AQE handle it. As we mentioned in episode 5, AQE can detect skewed partitions after a shuffle completes and split them automatically. It does this by looking at the real partition sizes and splitting any partition that is significantly larger than the median. This handles the most common case without any intervention. AQE skew handling has limits. It considers a partition skewed when it is more than a configurable multiple of the median partition size, by default around 5 times, and larger than a minimum byte threshold. Both are configurable. It works on the partition level, so it catches size-based skew well. It is less effective when skew comes from many different keys that are individually not enormous, but together create imbalance. And it does nothing before the first shuffle, so skew in the initial scan or an early narrow stage is invisible to it. AQE examining partition sizes after a shuffle, splitting one oversized partition into 3, labeled automatic but incomplete. So here is the right order to think about this. First, check for nulls and handle them at the source. Second, if the hot key is identifiable and stable, consider isolating it. Third, if you are on Spark 3.0 or later, AQE will catch the most common remaining cases automatically. Fourth, if none of the above is sufficient, salt. Salting is powerful, and it adds complexity. The others are simpler and should be tried first. One last honest note worth its own moment. Skew in a groupBy is annoying. Skew in a join is much worse. When you group by a skewed key, one task does more work. When you join on a skewed key, one task does more work and also potentially runs out of memory because it is building in-memory structures over a large fraction of a very large table. The partition that holds the largest share of your swites joined against the full merchant table may simply not fit in the memory allocated to one task, which connects directly to the next episode. Memory, spill, and why the job that was running fine yesterday is dying today. A skewed join partition overflowing its memory allocation with rows from both tables, labeled skew plus join equals out-of-memory risk. So here is the big picture. Skew happens when the hash function distributes keys unevenly, which happens whenever the data is uneven. One large merchant, one common null, one category that dominates. Find it in the UI by comparing median and maximum task duration. Fix it by handling nulls first, isolating known hotkeys, letting AQE catch what remains, and salting as a last resort when the skew is unknown and persistent. A summary strip reading find it, median versus max, then fix nulls first, then AQE catches common cases, then salt if needed.